It's Monday already. It's time for Let's Make It. This week we talk LED arrays. Bob is back and he's going to show us some really cool stuff with the LED array right after this. Let's Make It is brought to you by Ting, the new way everyone is getting their cell service. No overage penalties, great rates, keep what you do not use, no contracts, and someone will actually pick up the phone when you need support. Use our link and get $25 off your first month's service or your new phone. Just go to tech-zen.tv/ting to save $25. Hello and welcome to episode 24 of Let's Make It. This is an episode recorded on June 17th, 2013, and it's shortly after 9 p.m. And this week, we're going to talk about LED arrays. And I have Bob. You can kind of see him in the corner right over here. Actually, there's Bob right there.
Hello.
So before we get started, I want to remind you of one thing. Remember that YouTube, or moving our YouTube channel, so Let's Make It channel that's on YouTube is moving to the single channel of TechZen TV, which is youtube.com/TechZen TV. So if you're watching us on the old YouTube channel, just be sure to go over there and subscribe over there. We've actually had we're over 300 subscribers already over there, so we're gaining quickly, which is good. So it's 300 subscribers in the last week and a half or so, because we had 0 about 2 weeks ago. And that's good. Just keep doing that. Keep moving over there before we lose you. Because in another 4 weeks, we're not going to be on the old channel anymore. So this week, we have Bob back to talk with us about LED arrays. And he has some stuff to show us on his side of the stuff he's created for this week.
Okay. Well, I started off with the same chip that we used a couple weeks ago, the Maxim 7219. And let me show you the first. This is, here, let me start the sequence over. This is actually the code right out of the LED control example file. And the only change that we made was to slow down that Arduino, but it was actually a very simple code. Once I had the circuit figured out, it worked just fine. And that's actually where it took me a lot of time, was to figure out the circuit. So
we should probably say that you're using a bicolor array that's an 8x8.
Yes. Yeah, what you're looking at here is a working circuit and a failed circuit. So this is a bicolor display. Unfortunately, I don't have the green working. I had to pick a color, so I chose red. And the chips, the only chip that's actually in use is this 7219, hiding under this the mass of wires here. These other 6 chips that you see on the breadboard, none of them are actually used right here. What they are is 2 shift registers and a bunch of digital switches. And my idea was that I'd use the shift registers and the switches to turn on and off the columns, because this is a common cathode or common anode, and then they switch the cathodes by color. So I was going to use this extra hardware to switch between the colors, but what I found out was this chip is so specialized that it was not going to handle 2 colors, and given the disparity of the forward voltages of these LEDs. So I had visions of making red and green and amber, but it failed badly. The spec sheet, the data sheet that I found, which is actually wrong, had the forward voltage for the red is about at a minimum of 1.6, and I was finding 1.5 on my multimeter, and the green was at the maximum of 2.5. So given that disparity, it just wasn't going to work. So I left the chips and redid the wires, and of course, if I wanted to switch this to green, all I would have to do is move these 8 wires here to these 8 pins up here.
Right. I should probably also say that multiple companies make these LED arrays, and they're all a little bit different because I ordered some from Mouser and got from different manufacturers, and the pinouts are a lot different. So definitely look at the data sheet.
Yeah, and at least you bought you know, you knew what you were buying. I bought this one out of a bin at my local electronics store, and the data sheet that I found was the pin configuration was completely different than what the data sheet described, given the part number on the back of the matrix. So, and I had to go through pin by pin to figure out where the anodes were, where the cathodes were, where the red and green were. So it was actually time consuming and annoying, but you know, that's what you get for buying a part out of a bin sometimes. Yeah. So
that's right.
That's the fun of it. So
want to go over and look at the code you have is right from the sample, right?
Yeah, the only change was that I added in a longer delay time there's a function called write Arduino on matrix out of the example file, and I just added in a 1-second delay so we could read things as they scroll across the screen.
All right, so this is using the Max 72 chip, Maximum 7219.
7219, yep.
Okay, so setting up the LED control like we did in the episode 22.
Yes.
And then there's your delay time. And then you set up the chip. Again, shut down 0 means turn it on, which seems to me to be backwards. Or so shut down 0, false turns it on. False is what turns it on.
False turns it on.
Right, so it's chip 0, false to turn it on. And then he's setting the intensity to basically 50%.
That's actually, I had to turn it down for the camera. By default, this library actually sets it at 8. So 50% duty cycle. So I've got it set it as a 2 just to make it look good on the camera.
Okay. And clear the display. Now this code was written for a 5x7 matrix, and you have an 8x8, right?
This is an 8x8, and the code was written for an 8x8.
Oh, okay.
In the other demo, I've got funny letters, but
okay.
And then right there is the only line that I changed was that delay time. I changed it to a second. Everything else is right out of the example from the library.
All right. So these are the characters.
So that's where they're creating, and these are, you're right, these are actually 5x7 letters right here.
Right. I noticed when it's walking through that when it's all red and starts with the letters, it's only doing a 5x7 matrix. The rest of them stay on, so that's what I kind of figured. So yeah, basically each one of these is a row, correct?
Right.
All right. So you see the spelling out Arduino, Arduino. With 5 bytes apiece.
Yeah, and there's faster ways to program this, but they're being very specific to show you exactly how you display something to the screen. Which, when you're learning, this is a great way to. This was a very nice, it's a nice example to look at.
So here you see they're setting each row one at a time for the letter A, and they're waiting for the 1 second. And then they're setting all the letters for the R, all the rows for the R. And wait 1 second, and they do the same thing for the D, the U, and I, the N, and the O. And then they're basically blanking it out, right?
Yeah, and then the zeros are just turning off those rows.
Right.
And I think the way we're looking at it right here, I have rows and columns backwards. but
Okay.
in my display, because we're calling it a row, but it's actually a column on the display. So
Okay. All right. So here, the row is. What are they doing here? They blinking something?
this one they're blinking.
I see them turning it. Oh, this is the double dots that are going up and down. So there's an on, off, on, then there's more off. Yeah.
Right. So they're flashing dots.
Right. And they're doing it by row. So actually, I think the part of the code's coming up to do that. All right, so it's going down a little farther, and we're doing the same thing to the columns now. Actually, if you look at your display, you see that right there is when it's doing.
Yeah,
wow,
this
come on,
is
switch.
yeah, this is the rows. That's the rows. That's the columns.
Yeah, hang on a second.
And
There we go. Yeah, we missed it because I couldn't get the camera to switch. All right, we'll go back to the code here and keep walking through. When it comes around again, I'll pop back over there. So yeah, we're doing the same thing with the columns we did for rows right here.
yeah, that's right.
Blinking it off and on. And then this goes and lights up each one at a time, which is what we're doing right now. So what we're doing right now is we're going row and then columns. You're right, it's backwards because it's doing columns across and it's actually doing them down instead.
Yes.
So, which means your letters would be sideways. Right?
I rotated them.
Oh, okay. Okay. So, yeah, so you see they're going all the rows and then all the columns, and they're basically turning them on one at a time. And then they're going to turn them off, it looks like.
Yeah, they when they go to the next in the loop function, they go back to the right Arduino on the matrix.
Right,
but
okay.
because they don't clear the whole display, those three columns are left.
Yeah, so you see right here they're doing the rows, the 2 dots at each row, then 2 dots for each column. We walked by before. All right, so what else do we have down here? The right Arduino on matrix. Oh, that's that's when you're writing on the words on. Okay.
Yeah.
All right. So that's not a really long program. What is that?
No, it's
about 300 lines.
Yeah.
309.
And it's a nice, gives you a nice quick feel for how the chip is laid out and how letters can be displayed onto the screen. So it's a nice example.
Right.
That comes with this library.
All right. And then you want to go ahead and load up your other one real quick?
Yeah, let's upload that.
It must be loading because everything stopped.
Yep.
All right. So this is a program you wrote just to show what the capabilities are.
Yeah. Yeah, just a few various routines just to, show what it can do. And some of these look they look better when they're run faster.
Right, right.
But with the camera, we've got to slow it down a little bit. And then I added in letters that are based on a 5x7 array. And then the letters that I have are based off of a 7x7.
Okay, so the left or right one's always, and top one's always going to be blank.
Yeah. Since we spent a lot of time with letters and scrolling with this chip a couple weeks ago, I didn't redo all of that scrolling text and
right.
Yeah, this one it's fun to do, colorful little displays and actually this well that's this the scanning back and forth, I kind of like those, but this is the one I really like. This this meter effect.
Yeah.
That was kind of a pain to write, but it just looks cool.
All right, so let's go back over and look through the code. This is scrolling down here.
Now, when we go through the code, you'll see that I'm not finished with the. I was working on this afternoon and this evening, and but I haven't posted the code on GitHub yet. But by the time it's there, I'll have all the comments in.
Okay.
But the code itself is for this demo is basically done. I doubt if I'll add anything to it.
All right, so there you're adding all your numbers, 1 through 0. And then doing the same thing with the letters. Yep. Colon, dash, underscore, all on, and then checker.
And that checker is used for the checkerboard effect that we were looking at a little while.
Do you just XOR it?
Actually, I instead of doing an XOR, I did a well, we'll see it. It's basically I display it one direction and then turn around and display it the other direction.
Oh, okay.
So because I wanted to show what you could do, writing things one way and then writing things the opposite way.
Mm-hmm. All right. Then you have smile. I don't think we saw that anywhere, did we?
I took it out. It's cheesy. Not very good. And then space is just a blank.
Right.
It just blanks the entire display.
Okay. And then we go through the same process. We do the shutdown false. Set the intensity to 2. Then we clear the display. You see some of his debugging stuff in here.
Yeah, I've got it commented out here. Actually, this random function gave me a big headache this afternoon.
Yeah, we probably need to do a little discussion on random at some point and explain why you got to seed the random. Okay, so here's the loop. So you're going to set letter all on, which means you go all on, right?
That's right.
So set letters function you created.
Yes, that's right.
To put things out to the display. All right, and you're waiting 2 seconds and you're clearing the display. And then you do columns effect, which is another function that you wrote. What is it? The 100? Is that a delay period?
Yeah, it's like a lot of my other code. I try to write very generic functions. So in this case, it's to repeat the effect twice and delay between iterations 100 milliseconds.
All right. And then we clear the display. And then we do rows effect, which is the other direction.
Which is just the other direction.
And then we do the meter effect.
So it actually changes the screen 100 times.
Oh wow!
And then each screen change happens every 50 milliseconds. And then there is it actually cycles through a little more than that, because after 100 times, it has to drop each column back to 0. So there is a little extra code to turn it all, to turn it all off rather than just blanking the whole screen mid-display.
Okay. And then do the diagonal effect back and forth twice. Then we do the box effect and the checkerboard. And then we go through the letters. Well, actually, it looks like you're going through numbers first.
Go through the numbers first, then the letters.
And then the letter. What confused me is it set letter, but and then I saw numbers, like, oh, it's a number.
Yeah. Numbers and letters are the array. Set letter is the function. Yeah. Right. I've confused myself today too.
And then
this loop inside of a loop is actually a different way of turning on the entire array.
Okay.
Which I just stuck that in there so you could, because you could actually set. This is similar to the single
Right. This
function
just
than the other
happened
one.
so fast we didn't see it really.
That's right.
It looked to us
But
like
it's
a
just,
single block.
yeah, it displays so fast we don't notice, but I put that in there just to show a different way of turning everything on.
Right. All right. And then we come down and here's your set letter function.
And you can see where I don't have my comments finished.
That's okay.
So
okay, set letter basically is looping through all 8 columns.
it's going through the 8 columns. And what we previously created for any letter or number, those 8 binary arrays just get plugged in right here. So I do set things by column or by row.
Okay. Then the box effect. So you it looks like you have 4 different looks basically, and you loop through the loops, loop through the different looks.
Yeah, and go through the 4. You have the outer box, then the next one in, and then the 4. That 4th line, if you look at it real carefully, the only ones that are in there are the 4 LEDs at the very center.
Right.
And then it just separates. So 4 lines of code, and you're controlling the whole array, the whole matrix. And then that last set letter line right there.
Mm-hmm.
The first for loop, the int j, that's controlling the number of times you cycle through the whole thing. The first for loop, it's actually displaying all 4. Well, the second one, the center is already being displayed.
So you walk out 3 times,
so
basically.
I skip the center and just display the next 2, and then let the first for loop display the outer box. Well, when I finish, I have to show that outer box one last time.
Okay.
And you'll see that same idea.
Yeah, right here.
Somewhere else.
Okay.
And there's the box effect.
All right, so this is the meter effect.
Okay, so here's the meter.
So you basically set up an array of number of dots.
That's right.
Okay.
And I could have transposed all of these and had it go from the other side, the other direction if I wanted to.
Right. So, and then you have a random number, so you must be going to generate random numbers 8 times.
Yes, I've got 8. So for each, what we're looking at is for each column, the way it appears on the screen, each column gets its own. Although I use the set row function because I've got it
turned sideways.
I've got it turned sideways. Each column gets its own number, and then I have to keep up with an index because I need to know where am I in the display. To take the number up and down.
Right. All right.
Now this little while loop right here, and the reason I had the debugging code in here, this random function, the random 8, should give you a number between 0 and 7. That's the way the function works. And if you look further down, I actually tell it 0 to 7.
Right, I see
that. But for whatever reason, at the beginning of the code, that random function did not work for me. I would get numbers in the thousands returned to me. So that's why I have that little while loop built in right there, is to force it to give me a number that's between 0 and 7.
Okay.
So it's kind of that's not real good coding, and I shouldn't actually have to do it, but those were the random numbers that I was getting. But then later on, once it's set, it worked fine after that. So at this point, I'm at a loss for knowing why it was doing that.
Well, if it's a known bug, maybe somewhere.
Maybe. So that's why that while loop really we shouldn't need it, but I had to put it in anyway.
Okay.
because then the logic of the rest of the code wasn't working.
Right. Okay, so after you get your random numbers assigned,
I get 8 of them.
right, you get 8 of them, you're looping through
So there's one. The first loop is looping through the number of times that you told it how many cycles to run through,
okay,
and then the next for loop is
setting the row.
setting the 8, setting the 8. Well, as we see it, the 8 columns. But yeah, I'm
Right.
using the set row function, and then it starts off by displaying the index. Well, the index is always going to start at 0. But the number that was generated could be higher. So that's how you're getting the meter effect of it, of watching it go up and down.
Gotcha.
Because you have to start to 0, and then as long as the number, the index is smaller than the actual number generated, you keep adding to the index. And then when the two are the same, then you bring them both back down. And it's just an easy way of with just a few lines of code, being able to make them look like they're going up and down.
Right, right.
And then if the random number is back down to 0, then generate a new random number.
Okay.
And reset the index back to 0. And this makes each of the 8 independent from the others.
Right, right. Yeah, it's a little complicated, huh?
It is a little complicated, but it wasn't too bad. And then, of course, the delay duration right there, that's just waiting. Now that you've done all that code in a fraction of a second, now wait for the display, whatever time that you specified.
Right.
And then this last bit of code is kind of the same idea. It just takes every index
back to bottom,
0.
back to 0, yeah.
Back to the bottom in a way that looks natural.
Right.
And it uses the same duration function.
Okay.
I really like that one.
All right, so
well, I like making displays with random numbers because it makes every iteration, it makes it unique. So,
all right, so column effects.
Just what it says: turning on a column and going back and forth across the display, and just like before, to get the timing to work out right, that first for loop I cycle through all 8 columns. But then the second for loop, I only cycle through, and remember, this is a binary array, so the 8th column is actually array index 7. So I skip the 7 and go straight to 6, and skip 0, because the first array, or the first for loop, is taking care of the index 0 and 7.
Okay.
And then that last little bit of code just displays the last column, so it looks right.
Right. So whenever I was watching it go back and forth, it looked like they had 2 rows on. Is that just a visual effect of it moving?
There must be a visual effect. It's actually 1 column that goes across.
So you see it as 1 column?
Yes.
So let me go. It's almost there. So let me go over to there. See right there? To me, it looks like it's 2 columns.
Well, here, I tell you what.
Do you see it? You only see it as 1 column, right?
It is only 1 column.
It's just a camera effect, and that's all it is.
It's just a camera effect. Well, here, let me just I'll just cycle through it 1 time, and I'll change it to 250 milliseconds between cycles. All right, so new code is uploading. Maybe.
There it goes.
Here we go. Does that look like 1 to you? No, it still looks like 2. It's not slow enough.
It was better. It was definitely a lot better. So
Okay,
it's all camera effect then. So
it's camera effect. Okay, I just set it to half a second.
yeah, I just wanted to make sure that because to me, like you're doing like you were moving to one, then turning one off, moving to one, then turning one off. So I wanted to make sure that wasn't the case. Yeah, I mean, it's a lot better. You can see it's only one now, but you still get a little bit of effect when it's transitioning, but that's okay. It's all camera.
It's all camera.
Yep. Okay. All right, so we're just going down through here.
And then the rows effect is basically the same thing.
So at the bottom here, you're turning on the last row.
The last row, right.
Okay. And there's the rows effect. Just go in the other direction.
Just go in the opposite direction.
All right.
And really, you're right. I could have done I could have done this a little more efficiently, but I wanted to show how you could cycle back and forth through through the array. It really just more of a coding example than anything.
So let's see, set column. So how are you turning these around?
There's two in the second for loop. There's two variables. There's k, which controls the column, but now instead of using k,
oh, I gotcha. Yeah,
I use the variable j to, and because it's a checkerboard and 8 by 8, the first and the last columns are opposites of each other.
Right. I see what you're doing. When you said turn them around, I thought you were writing it as like one is row and one is column or something.
No, no.
Okay.
No, just playing tricky array pointers.
Yep. All right. And then diagonal.
Now there might be a better way to do this, but I haven't figured it out yet. But I did have to set up this diagonal to go all the way across the screen.
Okay. Yes, you basically are telling it what comes on for each movement.
Right.
Okay. And then you're just looping through that when you get down here a little farther. Yep. So okay.
And the same thing as before. You know, the second for loop, you know, takes off the ends. You know, the first and last display, and then you display the last one at the end.
All right. All right, and that's it.
And that's it.
All right.
And then we cycle through in the main display. We're cycling through the letters and the numbers.
Okay. And just to make sure that we talk about this, you are the extra chips that are on there are not really being used for anything currently.
Yes, that was showing my failed circuit.
Okay. You just want to make sure people understand that they're not in use.
Yes.
All right.
That's right. They are not in use.
All righty. So let's see.
Yeah, if I want to do both colors, and I may do it if someone's interested. The way to do it would be to have 3 shift registers, one controlling the anodes and one controlling the, one shift register for red, one shift register for green, and have the appropriate resistors connected, so I can balance out the colors and turn on and off columns, to create the colors.
Right. So you said this one has common anodes.
Yes.
So they're the cathodes are for green and cathodes for red, but they're all using the same anodes?
Correct.
So you can't really have a red and a green separate.
I can't you can't have them separate.
Right. So okay.
Well, you can separate them, but you turn off one or the other.
Right, exactly.
If you have both on, then of course you've got orange.
Right.
I think.
Yeah, some form of
something
orange.
Like amber, orange, something like that.
Right. Okay. So
And that's and it really comes down to the advantage of the 7219 is that you can control a great many effects with the chip very easily. The problem with it is that it's not going to control LEDs of different colors when their forward voltages are so different.
yeah, yeah, I was trying to think of a way you could still use it, but it's not really, wouldn't be an easy way. I was thinking like if you use two of them with only half of the anodes to drain on each chip.
Yeah, if you had two of them, you probably could be able to. You'd have to do a little coding so you're not colliding the two at the same time. But yeah, you could use two of them and control.
Yeah, I'm thinking
two,
like
and
it's almost like two separate matrices.
right, and then it would be treated as two separate matrices.
Right.
Well, the chips would see it that way. We, as the the writer of the software, we'd have to be aware of what's being turned on when.
Right. Exactly.
So yeah, a different setup. So the but this chip, just one of them was not gonna do a bicolor.
Right.
At least not this bicolor.
Right.
If it were green and blue, which have basically the same, most cases have the same forward voltage, then you could probably get away with,
or if each color has its own anodes.
Correct.
Would be another way of doing it.
Yep.
Then it would be really like having two matrices, because then you'd have separate matrices for each.
Right.
Which I think mine are common anodes too. I'm pretty sure. I think I can check, but I know they're not the same. The red and the green are definitely tied together. So
yeah,
have the same problem there.
Yeah.
All right. Well, I think that's what we wanted to cover for this week. Let me just go check on my notes just to make sure. So this will all be up on show notes. Bob said he's going to finish commenting that, and we'll stick it out on GitHub, and we'll put all that in the show notes as well. And the first program was actually from the playground, right?
The LED control library that I got from the playground, straight out of the playground, and then the letters that I used are actually from the playground as well.
Okay, great. All right, so I think other than a couple housekeeping things, we're pretty much done. You can subscribe to get us automatically. If you're watching us somewhere and you want to get us downloaded automatically without any worry, you can go to iTunes or any of your favorite podcast directories and sign up to get us all automatically. If you're out there on iTunes, please go out and give us a rating. That definitely helps us out a lot. You can listen to us now on Stitcher as well, and a couple other places as well. We also have a Roku app now. You can go out and watch all of our shows on the big screen if you want. Just hook it up to your TV if you have a Roku. Becoming a very popular device. I think we have like 11 or 12,000 downloads of that app now. So that's great as well. We do the show live every Monday night at 9 p.m. Eastern Time. Bob's actually, it's 8 p.m. for him because he's in Texas.
Yep.
So, but we'd love to have you come and join us in the chat room and chat with us out there. We do watch the chat room. It's like sitting right here in front of me. And we can interact with you. If you want to contact us outside of our live show, you can send questions or comments or suggestions for new future shows or anything like that to let's make it at tech-zen.tv. We'd love to hear from you, and we're getting 1 to 2 emails a day right now, and definitely take them to heart. And if you want to leave us a voicemail, you can call 913-732-3327 and leave us a voicemail. It's a Google Voice voicemail, so nobody will answer the phone. Don't worry about that part. Nobody's going to scare you and pick up the phone. But we'd love to get you. And if you have a project you'd like to show us, make a quick video of it on YouTube. Take your phone and record it and upload to YouTube or Vimeo or wherever you put your videos, and send us a link to it. And you may even see that in a future show as well. I think that is pretty much it for this week. Now, we had an email today asking about LCD thermostat via Zigbee. And next week, funny as it is, we had LCD thermostat on the schedule for next week. So we're going to do that anyways. So now we'll try to maybe incorporate the Zigbee. No promises, but we're going to try to do that for next week. So got to dig back to the Zigbee issue we had before. So, all right. I think that's it.
I think so.
Yep. All right. Well, thanks, Bob. And
Thank you.
We'll see everybody next week.
Good night.
All right. Bye. For show notes for this show, contacts, and more, go to the TechZen.tv website where you can get show notes for all of our shows. We love to hear from our viewers and listeners. We have an email, a Twitter, and a phone number where you can contact us for each show. For details, visit the TechZen.tv website and get the show details. You can also make a video and upload it somewhere like YouTube or Vimeo and then just send us a link. You never know, you may see your video in a future show. You can get all of our shows delivered automatically to your favorite device by going to your favorite podcast website like iTunes and subscribing. Each of our shows also has a YouTube channel you can subscribe to get regular updates. Our shows are also available on most internet radio networks like Stitcher and TuneIn Radio. You can also watch and listen to our shows on Xbox, TiVo, and Roku. You can even find us on your Zune.